So, don't know if there is anyone here just coming. Welcome to the robotic laboratory of Tecnalia. We're here in Spain, so we are pleased to be able to show you a little live demo that we presented in the ROSIN Industrial conference yesterday. You might find the entire presentation in the link of the yesterday's session about ROS and its industrial implementation. Feel free to ask any question you want in the chat of the YouTube link or in Swapcard. My colleague John will be pleased to answer you in Swapcard, and I'll trying to take care about question in the top chat. So here we have a demonstrator. The setup is coming with a Fanuc CR7 collaborative robot. In the end effector, we have mounted a vivid camera. I can show it a little closer in the simulation. So here you have the camera. Also mounted on the end effector, we have the... Yes, I start. Mounted on the end effector, we have three tools. The proper vivid camera, which is a high density and high velocity 3D camera, working with structured light. Also here you can see a Qualtech laser and a kind of drilling tool that we use to perform surfacing and evaluating. So we can run the demo if you want to. I don't know if there is anyone here, but let's go for the first one. So basically, the first step on this demo is to grab pictures of the scene with the camera. So using the vivid camera, we are grabbing a point cloud that we are recuperating here in the scene manager. And with this point cloud, we are doing segmentation to find out plane surfaces and edges. So with those segmentation, we are able to generate various trajectory. So let's say we want to plan trajectories for both surfaces. Here we are a dumb aluminum cube and a little more complex part. So let's generate spaces. The goal of this application is to provide some versatility to this kind of robotic application. So we can see here that we generated various trajectories. In blue here, you can see that we detected 3 edges. This one on the aluminum cube, and 2 other ones for this complex part, and also generated blend surfaces, blend trajectories that we allow us to make a path all over all the surface. So the interface we have here allows us to simulate those trajectory, to maybe validate that the robot is doing what we expected from him. and also able to reproduce it with the real robot. Just having a check if I have some question there. So we just generated automatically some trajectories, founding plane surfaces on the scene, and being able to reproduce it with the actual robot. The principal advantage of this kind of application is its very versatility, that we are able to work with different kind of parts that can be placed whenever you want in the field of view of the camera, the Zvid camera. So let's try to move the parts and trying to do another run with a new photo. So here we want to take a new image of the scene. So we moved the parts, and we found here one plane surface that we must select to generate automatically passes. Another time here we have generated three kind of trajectories. The first one in red is a blend trajectory, and the two others in blue are trajectories for the edge of the part. In yellow, you can also see that we have generated a trajectory for the scanner process. So we will execute all those trajectories. Let's start with the first one. So using this drilling tool we have mounted on the manipulator, we are going through the whole surface of the part. Let's go for the external edge trajectory. So you may have noticed that I did not place the part in a particular place. As having the place in the field of view of the Zvid camera is enough to generate the trajectory. check that I have some cushion or not. Seems not. So let's go for the inner circle trajectory. And finally, the scanning process. So here we are using a Qualtech Q4 laser. This enables us to verify that the process has been performed correctly, generating a second point cloud that we can compare eventually with a CAD file that is representing the part before it's after the process. So I'll have a look at my son. It seems that it may be a little low. Hope I can fix that. So here in blue, you can see that we generated this second point cloud coming from the laser sensor. That is an additional point cloud that we can use to make quality check. So about sound. Is this better? I hope my colleague will be able to say me if not. I tried to raise up the sound. Okay, I've still have no question in the YouTube chat. Having a look to swapcard. Don't think so. So let's go for another run. Yo lo he subido, a ver si tú notas una diferencia. Puedo seguir subiendo, ¿no? Pero tope, dale. So let's go for another run. So we are taking a new photo, which will be exactly the same as the previous one. We didn't move the setup, but we are actually working with a new point cloud. As you can see, we've detected this plane surface thanks to segmentation, and we are now generating trajectories. We are generating three kinds of trajectories. A blend surface trajectory that will be cover all the surface of the part, and two edges trajectories that are corresponding to the edges we detected during the segmentation process, which you can see in blue here, and the yellow one, which is corresponding to the scan process. So let's simulate all those trajectories. You can see that the LAV's panel is actually showing two different robots. Was intended to simulation, and the others is the actual state of the robot, the real robot. So the force trajectory has been simulated correctly. So let's have a run with the real robot. By the way, I will be checking if I have any question. Yes, my colleague Jonas Piasso is asking me to give some detail about the what kind of application this framework can be helpful. So actually, industrial are facing different problematic with robotic programming, and having everyday production with a high number of parts, of different parts, maybe some parts coming from partner without CAD files or this kind of thing, being able to recall the point loads and to add some perception in the programming process can be quite interesting. And here ROS is providing useful tools to facilitate a lot this kind of application. And more than those, we are using almost all ROSIN FTP's project. The driver from the FANUC robot is coming from an FTP as a driver for the vivid camera. We actually designed a custom driver for the Qualtech laser that we are currently using. As you can see, anticipating the point load coming from the laser sensor over the point load coming from the perception process. And so this kind of application is mainly to demonstrate to industrial actors that the ROS framework is growing every day and providing new tools that are significantly oriented to their actual problematic. So maybe we can switch the part which we are using. So I just swapped the part. We are now with a dumb aluminum cube placed in front of the robot. Let's go for a new photo. You might notice that the perception process is quite quick. This is thanks to the vivid camera we are using. Another time the driver we are using is actually a product of an FTP ROSIN project. So to look a little more about that, you can see that the point cloud we are gathering is quite fine and precise. There is not a lot of cameras that are providing this kind of precision, so it's quite great, this sensor. I'll be pleased to work with it. So once we capture the photo, let's select the surface we have detected. Here we found one plane surface. And let's generate some trajectories. Here we detected one edges that has been converted to a trajectory. We're also seeing that a blend trajectory inside of the surface have been generated. And in yellow, you can see the trajectory corresponding to the scanning process. So let's simulate this blend trajectory. So being simulating this process may be useful when you are trying to work with the new parts to verify that the robot is having a behavior corresponding to what you expect from him. Once you are used to the part you want to process, it's maybe not relevant to simulate the process every time you want to use it. But it's kind of security to ensure that everything is doing correctly. So here the blend trajectory has been executed by the robot. Let's go for the edge trajectory. And finally, let's go for this scan trajectory. So here you can see the simulated version of the Qualtech model, and what we are gathering here in the Revis panel is actually live data coming from the sensor. So we have plenty of different parameters that are available to custom the process as you want to. For example, we might want to make several photos with coming from different points. This can be useful if you want to work with a part that is bigger than the field of view of the camera. We are actually able to gather in various point clouds and consider them as one. You can also change the pose from where you want to take the photo. Not sure how you will, but now I must be able to take two different photos from two different points. Oof. Seems we had a reflect. So you see we have been taking two photos. Here there is an artifact coming from a reflect on the part. So we don't want to consider it. So let's unselect it. And now we have this plane that has been detected using the both photos taken by the Vivid camera. And let's go to generate some trajectories. Oof. We still have some problem with the segmentation part. If you're interested to, maybe we can talk about it. Actually, the reflect has produced some 9 points in the point load, and the segmentation algorithm do not like 9 points. So let's restart the application. Unfortunately, we lose the photo we just taken, but can produce another one without any difficulties. Let's go for 2 photos. So here the perception process has been performed correctly. We detected one part on the field of view of the camera, select it, and generate species. Other options are available for the generation of trajectories. We can choose to use different kind of trajectory, more linear, not considering the biggest polygon, concave polygon of that is containing the plane we are seeing. Might change the discretization of the trajectories to have a finer trajectories, or at contrary with more spaces in between points. We can eventually customize the scan width, the radius of the tool we're using. All those parameters will affect the behavior of the planner. So here we have already generated trajectory. So we had some singularities here that used to be caused by some reflex on the part of this kind of noise that can be found in the perception process. So here the 3 edges trajectory we generated are not very relevant. But the blend process seems to have been performed correctly. Let's go for a simulation. seems good, so we can execute it. So we might want to see what's happened with those edge trajectory. So before trying to execute it with the VR robot, it's maybe preferable to simulate those. You can see that, I don't know if there were some strange light on the part, but we did not perform a correct segmentation. This one seems quite similar. And also this one has some singularity issues by the end of the trajectories. So maybe let's come back to one, or trying to keep two photos and changing the parts we are using. So here we go. Let's have a new photo. Thanks. Seems that RAV is shut down, but the application is still working. So here we are just able to see the second photo, but here you can see that we are considering also a part of the point cloud that is not present in this photography. As I was saying before, we are actually using a concatenation of all the photos we are taking to perform the segmentation process. So oof. LFV seems to having a bad life. Let's retry restart the whole application, be sure that we did not have any strange configuration. Here we are. So let's continue with two photos. And running the perception process. See, you can see the first point cloud we are gathering. And here is the second one. In few seconds, you will see the result of the segmentation process. So here we detected this plane, which is a result of, which is generated with the 2 point clouds we just saw. Seen? Sorry for that. And actually, we are just looking for plane in the different point clouds we are gathering, but we can imagine to introduce the Noether panel, which is also available in for this application, to be able to perform the same application but with uncurved, with curved surfaces. So let's select this plane. I'm going for the generation. It seems that we have some singularities on the edge trajectory generation. Let's have a look about it. So the blend process seems to be generated correctly. This edge is not entire. I don't know why the segmentation did not consider the whole continuous edge trajectory. Here we have the second part of this trajectory. It seems that the algorithm did not find some pointer there. And here, the inner circle trajectory seems a little weird also. Let's simulate it to see what's happening. You can see that there is some strange points here inside of the circle. The blend process seems correct. So let's execute it. So it has been performed correctly. Let's go for the scanning process. Just having a look if I can't find any question here. Seems not. So here with the Qualtech laser, we are generating a second point cloud. That is corresponding, in fact, to the part after the drilling process or the surfacing process. This could be used for quality checking or this kind of application you want when you want to check that the process has been performed as you expected. So this could be compared to a CAD file or any kind of reference model that you want to. So maybe let's moving the parts another time. Now let's have a new photo. So here we have two parts on the field of view of the vivid camera. We have detected here two planes that we can select to generate different kind of trajectories. Oh, seems that the inverse kinematic has encountered some problem here. I think that we can move a little the parts to be sure that that's it. They can fails for some trajectories. In fact, we generate the Cartesian trajectories. The problem we're just getting here is that in this current position, the robot will not be able to reach all the point of the trajectory, ensuring that there is no collision between the robot itself and its environment. So let's move the part a little bit. So let's go back to a new photo. Another time we have detected two surfaces. Hello, Dave. Actually, I'm using a VNC client to share the desktop of a Ubuntu PC. So it's not really available online, but the GitHub repository will be released soon. And maybe my colleague John can give you some more detail about it if you want to. So here we have generated 6 different directories. We have actually generated blends for both parts. The edge trajectory has been plan correctly for these square pieces. And we found some different edges here. Still experimenting some problems with this, the continuity of the edges. Some improvement could be made here, but in fact this demo has been specially mounted to show that the industrial field of application for the ROS framework is growing every day, and actual industrial actor may find this kind of application with high versatility quite interesting. So this can be thank you, Dave. We've made some improvement on this repository. I hope it will be. I hope it will be released soon. So let's have a look at the simulation to ensure that everything is working properly. So with this square part seems good. We have little singularity here. I don't think that it will provide us any problem to execute it with a real robot. So let's go for that. So in fact, we have been able to mount this scan and plan application using the Godel repository that my colleague just mentioned. But we have significantly modified it. In fact, we are using a new robot, changing from the big industrial ABB robot to this Fanuc collaborative manipulator. Also change all the sensors the application is using, switching to the vid camera, which is a high precision and high velocity 3D camera working with structured light. We also have mounted here a laser from Qualtech. This one is the Q4. And a drilling tool. So those three tools are mounted on the manipulator. So the goal here was to show that ROS providing a very interesting tool for how to say it clearly, to enhance the accessibility to complex application of robotic, online and programming and automatic generation of paths without having a really big challenge. In fact, we are trying to demonstrate that ROS is being mature enough to be integrated in industrial field today. Sadly, this demo was planned to be presented during the Grid Feria here, the Biennale International of Machining Tool. This should have been taken place in Bilbao in this month, this year during May. But as you know, with the COVID crisis, it has been difficult. So we have been able to share the result of this application with various kind of people visiting here the robotic laboratory. We actually show this demonstration to various students coming from university. Also, some local manufacturer has been quite impressed by what they have been able to see here. And we had some and also been able to show it to big manufacturer as Repsol or guys from Kawada. Please feel free to contact us, Dave. So let's continue with this demonstration. Sadly, we did not success to solve the inverse kinematic for the scanning processes. Sorry for that. Let's have a look with this big blend trajectory. Seems quite good. So let's perform it. The segmentation could be also improved and the path trajectory generation. As you may see, the hole in the part is considered as part of the plane. So we are actually generating pace through it. To go further, it would be interesting to have a closer look to the segmentation and eventually consider those parts with a different approach. So let's move the parts the last time. And let's take a new photo. So here is the point cloud coming from the vivid camera. In there, thanks to segmentation process, we've been able to detect the plane. You can see that the generated point cloud is quite thin. This is an amazing sensor to work with. The camera, the vivid camera is providing us good data for this kind of application. So let's generate some passes. The time the scan process did not. But it seems just edges has been found correctly. So let's execute those trajectories. So you might notice, yes, just moving the part and changing the orientation of the part in the scene does not really affect the path generation. It may affect the solving of the inverse kinematic. In fact, with this configuration, the tool might be entered in collision with the upper arm of the robot, but the pieces are almost always generated. We may have a look here. You can see that all those weird information are significant evidence that some point of one of the trajectory has not been has not encountered a solution for the IKEA solver. So I think that the ROSIN conference will soon start back. So I hope that you learn something here, you find it relevant, and please feel free to contact us, me or my colleague Jonas Piassou. You can find us on LinkedIn on the SwapCard app. Please feel free to ask us if you want us any compliments to this little demonstration. Hope that you enjoyed this little live streaming, and another time, feel free to contact us if you have any doubt or any question about this application. Thanks you all, and goodbye.